This is the start of the binary section. There's a lot of topics in binary. So these are all the things you're going to be looking at over the entirety of the AS binary. So what binary is, 2's complement, sign magnitude, so negative numbers, floating point, fixed point, and hexadecimal, and also addition and subtraction in binary. So it's a little bit of background. So a single bit is a 1 over 0. So we call the 1 zeros bits. A byte is made of 8 bits and is traditionally used to store a single letter on the screen using ASCII. A nibble. Now, normally we'd use our standard numbers, and we call it denary. If we wanted to represent the 42, we can think of it as 4 tens and a 2. So if I looked at this number, we got 4251, so 4,251. So I got 1 1, 5 tens, 2 hundreds, and 4 thousands. Okay, so if I add all those numbers up, I'd get 4,251. Denary, our normal numbering system, is base 10. It's called base 10 because there's 10 possible values for each digit. Okay, so starting from 0 all the way. In binary, we call it base 2 because there's only 2 possibilities. Now, instead of having 1,000, 100, tens, and ones, we've actually got 1, 2, 4, and 8. These are calculated in the following way. So because it's base 2, we put a 2, and then we raise it to the power of the column number starting at 0. So 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8, and so on and so forth. The easy way to remember it is they double each time. So 1 doubled is 2, 2 doubled is 4, 4 doubled is 8, and so on and so forth. So let's say we had this binary number made up of 8 bits. We can write it out and then write the values up on the top in the same way as we would have done when we were learning normal numbers. So we've got 128, we've got 132, we've got 116, a 2, and a 1. So all we do is add them all up and we get the final value of 179. So that binary number at the top is 179. Okay. Again, remember that the numbers double each time, so 1, 2, 4, 8, and it also starts going from this direction. Okay, a common mistake beginner binaryists do is do it the other way around, and obviously you get a completely different number that way. So again, let's have another look at a number. So here's a binary number. Again, we write it out, and this time we've got 32, an 8, and a 4. So adding all those up, you get 44. Now, if I had 8 bits, the largest number I can store is basically all the ones. If I add all those numbers up, what do you think I'm going to get? The answer is 255. Now, there is a quick way of working out using this simple formula here, 2 to the power of n minus 1, where n is the number of bits I've got. So 2 to the power of 8 is 256, minus 1 is 255, and that's how you can work out the largest number. So now's a good time to pause and have a practice. So here are some questions. And here are the answers. So if you want to check your answers, do have a go at them yourself rather than just simply looking at this. The question is, how can we continue on? So here's a much bigger number. So this is 16 bits. How could we work this one out? The answer to this is 19,560. To work it out, we can work out the bits. So that bit there is 8. So 1, 2, 4, 8. Then 16, 32, 64, 128. And you can see they're going to keep going. So 256, 512, and then so on and so forth, 1024, and so on and so forth. Okay, and if you kept going, that's how you'd get that answer. So converting denary into binary is a little trickier, but it's fairly straightforward. So the method is simple. You find the biggest column value, or the power of 2, which when subtracted from a number will not be negative. You then subtract that value and keep repeating until you get 0. So here's, because that sometimes does make sense. Let's say I want to make 153 into binary. I start off with the biggest column which is 128. So subtract that from 153, which leaves me 25. Well, 64 won't work because if I did 128 plus 64, that's too big. Same with 32, but then I can 16. So 16 is smaller than 25, so I can subtract that, put a 1 there, and that leaves me 9, and I can keep going. I can use an 8. So 9 minus 8 is 1. Well, 2 doesn't fit, but 1 does. So working out in its entirety, that gives me that binary value. So 128 plus 16 plus 8 plus 1 is 153. A little tip when you're working out binary, just again to check if you got the right answer. If it's an odd number, you're always going to have a 1 at the end here. So if we're going to convert 84 into binary, 128 doesn't go, but 64 does, which leaves me with 20. 20 minus 16 is 4, so I'll put a 1 underneath. Then 4 minus 4 is obviously 0, so I'll put 1 there, and then that's done. So adding those up, that gives me 84. So another activity, have a go at converting those into binary. So I'll pause here. And here are the answers, okay? So please do check you got the correct answer. When you have 8 bits, there's only so many numbers you can fit in. We call it fixed size. These can't get any bigger. So if I try and store something that's bigger than I can store in 8 bits or 16 bits, whatever happens to be, we're going to get strange results. We call this situation overflow. So I'll give you an example. Let's say I'm trying to store the number 356 into 8 bits. The problem with that is I'm going to need an extra bit at the end. I need 9 bits to store that number, not 8. So if I take that number off, I'm left with this binary value. Okay? And that is not 356. It's actually nowhere. So I get a weird value of 100. So when we've got overflow, essentially that means that the number I'm trying to store is too big for the number of bits available. So here's the time for another example, an activity. Work out what these numbers are, but only using 8 bits. You're going to get overflow on each and every one of these. Just write down what the real number will be. So here's the answers. So that's 432 in binary. That's it, only 8 bits. So I basically take just the 8 bits here. And then that actually gives me 176. So I get the wrong answer. And the same happens for all of these here. So when we get overflow, we'll get the wrong answer because we are trying to store a number that's too big. There is another way of converting binary using a division method. You can read more about it on the web's link on the screen, or just Google how to convert numbers into binary. You'll get the other version. Now, the next 2 slides, I'm going to show you 2 games which you can play to practice your binary. They're a little bit of fun, but they'll help you get faster at doing binary. Okay, to play this game, it's quite simple. You see a number down the bottom, and then you've just got to make that number up using binary. So 4, 1, 0, 0. This is another game to practice your binary. So here you've got a number, and you've just got to make it up. So 10 is 8 and 2. When it's got the number missing here, you just type in what that number is, which is 2. And you just play like that, and the idea is to try and get rid of them as fast as possible.